In part 1 of Lecture 3, we will answer the question, what are objects? Object-oriented programming, or OOP, attempts to allow the programmer to use data objects in ways that represent how they are viewed in the real world, with less attention to the implementation method. If, for example, I were looking at a space game where I have a spaceship on the screen, I would be concerned with its altitude off the ground, its attitude, is it pitching forward, back, left, or right, its position over the planet, its speed. But I don't want to be thinking about the pixels I'm turning on and off when I'm working on that higher level of abstraction. In this, an object is characterized by its name, its properties, the values that it contains, and its methods, procedures, and operations that are performed upon it. There are 4 main principles that guide object-oriented programming. Data abstraction. Our main concern is what data represents and not how it's implemented. We really don't want these implementation details to be the concern of anyone using objects belonging to this particular class. Encapsulation. Private information about an object should be private and not available to the outside world, and only used in pre-specified ways. This simplifies the whole process of the interaction between various parts of the program. Polymorphism. There may be more than one version of a given method, where the different versions may share a name but have different parameter lists. They may fundamentally be the same operation by definition, but the details are different. And this way we don't have to worry about which one we're using, we simply let the parameter list guide us. Inheritance. New classes of objects can be built from other classes of objects. So if I have a class called motor vehicle, I can derive from it classes called motorcycle, automobile, SUV, truck, and whatever else I might think in terms of. An object in Java will have methods. Methods are its own procedures. It will also have properties. Properties are its own variables and the values those variables have. There can be more than one method with a given name, but that requires that the parameter lists must be different. When objects have the same sets of methods and the same sets of values or properties, we will usually organize these as classes of objects. We will talk more about how classes of objects are defined a little later. Java has standard classes, classes that are pre-written and supplied as part of the Java Development Kit, or JDK. These standard classes allow you to read and write text from the keyboard and to the screen, as well as to and from files, to create graphical interfaces, and even more. Scanner is an example of a standard class in Java. The scanner class allows us to use text files, the keyboard, and even strings of text as sources of input. Like any other class, using it involves creating an instance of that class, an object, and initializing it with a constructor call. As you see here in this example, something we've seen a lot of, scanner keyboard equals new scanner system in. Scanner is the name of this class of objects. Keyboard is an object being declared as an object belonging to this class. We call the constructor by writing new scanner, and the parameter that we give to the constructor is system in. The assignment means that there's going to be a reference to the object, and we want to pass this on to the object itself. What exactly a reference is something we will talk about in the next couple of weeks. Like other classes, standard classes and user-defined classes, Scanner has many methods, a few of which we have already seen. Next, which returns a string of characters, up to the next whitespace character in the input. Next int returns an integer value that is next in the input. Next double returns a double value that is next in the input. Next line, which returns a string with the remainder of the input line. These are just a few of the methods contained within the scanner class that are available to us. A class is similar to a data type, except that the data items that it contains, the data types of which these items are declared, and the operations performed by them are all declared by the programmer. An instance of a class, similar to a variable of a given type, is called an object. The data contained within an object is called a property. The actions or operations performed by an object is called a method. To declare objects of a given class, we write my class, object 1, equals new my class. If I write my class, object 2, object 2 has no value until I write object 2 equals new my object. Only after calling the constructor can I actually make use of the object. We're going to develop a class called date, and this is an effort that will continue through all of this lecture set. We'll start off with the first try, and we'll give it 3 properties: month, day, and year, with month as a string and day and year as numbers. We'll also write a method called writeOutput that will print the date in a format that we would normally want to see it written in. We begin public class date first try, open brace. Now we'll write public string month, public int day, public int year. After the semicolon, we'll have a comment that is a 4-digit number. So with it, we're not just abbreviating the last 2 digits of it. These are the 3 properties in question. We'll write the method beginning with a comment. WriteOutput, write the date in a proper format. Now we have public void WriteOutput, open close parenthesis, open brace, system.out.println, open parenthesis, month plus a blank in quotes, plus day, plus a comma and a blank in quotes, plus year, close parenthesis, semicolon. We will now close the method with a close brace, and we'll close the class with a close brace. Notice the absence of the word static here. Static here would indicate that there could only be one instance of the method ever at any given time. That's not what we're using here. We're going to have different instances of this available for every time we create a new date. Let's take a look at test first date. This is going to make use of our first try at writing a date class. Public class test first date, open brace. Now that we're inside the class, let's write public static void main string args, open brace. Inside the method, we write date first try, date 1, comma date 2. Now, before we can use them, we must call the constructors. So we write the comment, call the constructors, now we can use them. And we write date 1 equals new, date first try. Date 2 equals new, date first try. And now that we are ready to start using them. We'll initialize date 1. Date 1 dot month equals, quote, December, unquote, semicolon. Date 1 dot day equals 31. Date 1 dot year equals 2006, semicolon. System.out.println, and inside the parentheses, date 1 colon inside quotation marks. Date 1 dot WriteOutput. Now, the properties that you see here belong to date 1, and we show that by having the name of the object before it and a period. With date 1 dot output, we're showing that there's an instance here of the method. This belongs to the object, meaning that write output will be working with month, day, and year belonging to date 1. It knows that from how we've written it. Now we will initialize the properties in date 2. Date 2 month equals, quote, July, unquote, semicolon. Date 2 day equals 4. Date 2 year equals 1776. System.println, quote, date 2, colon, unquote, close parenthesis, semicolon. And lastly, date 2 dot write output, open and close parenthesis, semicolon. In this, we have given values to date 2, and we've printed out a label for it, and we've printed out the date. We close the method with a closed brace, and we close the class with a closed brace.